Hello and welcome to my video. Today we are going to solve this system of equations. So the first one is log base a of x plus log base b of y equals c. And the second equation is log base b of x plus log base a of y equals d. And of course, since this a and b are the basis of the logarithm, they must satisfy the conditions for the base of the logarithm. So they must be positive and they cannot have values of 1. Alright, let's solve this problem. We have different bases for x and y, so let's deal with that first. We can use the famous base changing formula of logarithms, where we can introduce new base k using this relation. And here, let us change the bases into 10, so we express everything in common logarithm. So for here, log base a of x can be expressed as log base 10 of x over log base 10 of a. And I will just write log base 10 as simply log, which is a common notation for the log with base 10, the common logarithm. Then for the first equation, we have log x over log a plus log y over log b equals c. And for the second equation, we have log x over log b plus log y over log a equals d. Now you can think of this as the system of linear equations of log x and log y. If we even use the following substitution, where we denote log x and log y as capital letter X and Y, and 1 over log a as capital letter A, and 1 over log b as capital letter B, then the equation looks much simpler. So we can clearly see that the equations are linear equations of x and y, and although it is a bit difficult with parametric coefficients instead of numeric coefficients, it is still solvable. However, I am not going to do that because this problem is simply not that difficult to deserve such substitution. So I am not going to use substitution and simply going to solve this system as it is, like a true boss. So first, let's find log x. In order to do that, we have to eliminate log y. Coefficients for log y is 1 over log b in equation 1 and 1 over log a in equation 2. So in order to eliminate log y, we must perform equation 1 times 1 over log a minus equation 2 times 1 over log b. So if you multiply 1 over log a on both sides of equation 1, we have log x over, now this part becomes log a squared plus log y over log a times log b equals c over log a. And if you multiply equation 2 with 1 over log b, we obtain log x over log b squared plus log y over log a log b equals d over log b. So if we do the subtraction, you can see that log y is eliminated. And for the coefficient of log x, we have 1 over log a squared minus 1 over log b squared equals c over log a minus d over log b. Now for this part, it is equal to log b squared minus log a squared over log a squared times log b squared, and we have times log x equals, and if we do the similar thing in this part, we have c log b minus d log a over log a log b. So now we can cancel out log a times log b on both sides, and log x equals, so this must go down and this must go up, so we have log a log b times c log b minus d log a over log b squared minus log a squared. And for the x is simply 10 to the power of this entire right hand side. So we have 10 to the power of log a times log b times c log b minus d log a over log b squared minus log a squared. So this is x. Now let us obtain log y. Obviously, now we have to eliminate log x. So we must perform equation 1 times 1 over log b minus equation 2 times 1 over log a. And let's quickly do that. So if we do the subtraction, now log x is getting eliminated, and we obtain this result. So now we have this, and similarly, this log a, log b got cancelled. So log y equals log a, log b, c log a minus d log b over log a square minus log b square. However, we obtained this expression for log x, and the denominator was log b square minus log a square. So let us use the same denominator with x. Then we have log y as this denominator, and in the numerator, now this part becomes d log b minus c log a. So for y, we have 10 to the power of log a log b d log b minus c log a over log b square minus log a square. And this is the expression for y. So if we rewrite the solution, we have this. And this is our answer. Thank you for watching, and I will see you in another video.